Our goal in the next few lessons will be to calculate the price of a call option. We will apply the Black-Scholes-Merton formula we introduced in our earlier video. In the next lecture, we will give you an example of how professionals sometimes use more complicated mathematical tools to obtain better results. There will be nothing to plot here, so please import NumPy, Pandas, Pandas Data Reader, and the Norm module. Now we are ready to start. In this exercise, we will create functions that would allow us to calculate the D1 and D2 numbers we'll need to apply the Black-Scholes formula and price a call option. The parameters to include are the current stock price, S, the strike price, K, the risk-free rate, R, the standard deviation, and the time horizon measured in years. I am sure you have a well-trained eye to spot the formulas easily for D1 and D2 written in this cell. The only difference between the two numbers is that in D1, we add the variance divided by 2, while in D2, we must subtract it. Okay? To apply the Black-Scholes formula, we won't need the PPF distribution we used when we forecasted future stock prices. Instead, we will need the cumulative normal distribution. We will not dig deeper, but please assume statistical theory leads us to use the CDF in this case. Since the cumulative distribution shows how the data accumulates in time, its output can never be below 0 or above 1. 1 is the last point in the graph, which illustrates how data has been accumulated. So, Norm CDF will take as an argument a value from the data and will show us what portion of the data lies below that value. For instance, an argument of 0 will lead to an output of 0.5, since 0 is the mean of the standard normal distribution, and half the data lies below this value. An argument of 0.25 entails 0.6, and an argument of 0.75 approximately 0.77. Such a large argument as 9 results as 1 because it is expected to be the largest data point in our set. We can introduce the Black-Scholes function. It will have the same parameters as D1 and D2, current stock price, strike price, risk-free rate, standard deviation, and time horizon measured in years. Observe how the formula shown in the box is replicated in Pythonic. This piece refers to N of D1. It is multiplied by the stock price, S. From this amount, we must deduct the product of the strike price, K, e to the power of minus the risk-free rate times T, the time horizon, and N of D2, which translates into the value of the cumulative distribution function with an argument the function D2. From a Pythonic perspective, this is an example of how we can use a function within another function. Great! Okay, we defined all the necessary functions. Let's apply them for P&G. I'll download data from the 1st of January 2007 again. Then the iLook method with -1 written within the index operator will deliver the current stock price. We have a value for our variable S. Another argument we could extract from the data is the standard deviation. Now, we must mention professionals usually apply certain formulas, or as they say, interpolations, to compute this value. In our case, we will use an approximation the standard deviation of the logarithmic returns of this stock, and I'm sure you can do this with your eyes shut. We will store the obtained output in stdev. Okay, let the show begin. We can calculate the price of the call option. We will stick to a risk-free rate of 2.5% corresponding to the yield of a 10-year government bond, as shown in Bloomberg, the one we used in one of our earlier lectures, remember? Let's assume the strike price equals $110 and the time horizon is 1 year. All right. At this stage, we have values for all 5 parameters we are interested in. If we employ them in the 3 functions we created, we'll be able to solve for D1 and D2, and then obtain the call option price. It is close to $1.68. Wonderful! We were able to price the call option. Is it possible to have a call option price so much lower than the actual stock price? Yes, absolutely. The value of the option depends on multiple parameters, such as strike price, time to maturity, and volatility. It is not directly proportional to the price of the security. Here, we showed you how to calculate the price of a call option with Python. If you rerun the same code with different values for the time to maturity period, standard deviation, or strike price, you will obtain a different option price. Professionals implement a lot more complicated mathematical formulas and loops to specify the call within a millionth of its value, because when investing tens of millions, infinitesimal differences matter. Follow us in our next video, where we will show you how we can calculate the price of a stock option in a more sophisticated way. Thanks for watching.